Today we are tackling a pretty big question and one that you sent in, which is, could humans actually live on Mars?
Yeah, it's a big one.
It is. We've been sifting through this massive report all about it, trying to kind of extract the most crucial insights. Looking at the Martian environment, what living on Mars would actually do to the human body, and what incredible technology is being developed to try and make it happen.
Right.
Our mission is to leave you feeling well informed about all of this, but not completely overwhelmed, because like I said, this report is dense.
It is. The thing that just jumps out at you right away reading this is just how different Mars is from Earth.
Yeah.
And not just like a little bit different, like fundamentally different.
Right.
Like it's almost like this planet's actively trying to keep us away.
Yeah, and the report makes that very clear.
Yeah.
So let's actually start with that. Let's talk about that environment and how it's so unwelcoming. Like, first of all, you've got the atmosphere.
Right.
It's 95% carbon dioxide. There's basically no oxygen to speak of.
Yep.
We'd have to bring our own supply. Full stop.
You got it. Full spacesuit anytime you step outside.
Okay, yeah. Let's talk about the pressure. Less than 1% of Earth's. I mean, you step outside without a suit, your blood would boil.
It would.
It's wild.
Yeah.
And it's so cold, too. I mean, averaging negative 85 degrees Fahrenheit. Huge temperature swings, right?
Yeah. The report dives into this. The thin atmosphere is what's causing those extreme temperatures. But actually, what I found maybe even scarier was the radiation.
Okay.
It's 40 to 50 times higher than what we experience here. No global magnetic field to protect us. And that thin atmosphere isn't doing much to shield us either. So we're just bombarded with solar and cosmic radiation.
40 to 50 times. Wow, that is scary.
Yeah.
And the report details some pretty serious health risks. Cancer, neurological problems. I mean, shielding is non-negotiable.
Oh, absolutely.
Okay, so another thing, water.
Right.
There's no liquid water just out there on the surface that we know of. But the report does highlight a significant amount of water ice at the poles and underground.
Yes, the ice is there. And the report even hints at potential for underground reservoirs of liquid water. But the challenge is, how do you get to it?
Right.
How do you extract it and purify it in this crazy environment? It's essential, though, for everything. Drinking, growing food, making rocket fuel.
Absolutely crucial. Okay, so let's say, hypothetically, we figure out a way to deal with all of that.
Okay.
The elements, the radiation. Let's talk about what Mars would do to our bodies.
Right.
Well, the gravity is much lower, about 38% of Earth's. And the report says that would cause some pretty significant bone and muscle loss. Like, we're talking 1.5% bone density loss per month.
Per month, yeah.
Yeah.
And we're not even sure what the long-term effects of that would be. We have some ideas.
Yeah.
We're going to have to be exercising constantly, that's for sure.
Yeah. The report also talks about how that weaker gravity would mess with the fluids in our bodies, cause like facial swelling, congestion. Our hearts would get weaker. They're even worried about vision changes over the long term.
Right. And let's not forget about that thin atmosphere we keep talking about.
Right.
It's not just the pressure. We're talking hypoxia because of low oxygen,
Right.
severe dehydration because the air's so cold and dry.
Yeah.
And you know what else? Almost no ozone layer.
Oh, wow.
So the UV radiation risk is through the roof. You're thinking really bad sunburns, increased risk of skin cancer.
It's relentless.
Yeah.
It really is. And then we've got that radiation we were talking about earlier.
Right. The ever-present danger.
DNA damage, increased cancer risk.
Cardiovascular damage.
Yeah.
It can hinder the production of new neurons, leading to cognitive impairment.
Yeah.
Shielding's not just important. It's absolutely essential for any long-term presence on Mars.
Right. Mars is tough. I mean, really tough.
It is.
But humans are pretty ingenious too, right?
That's right.
So let's talk about some of the technological solutions that the report dives into.
Okay.
Habitats, building on the surface, using Martian soil to help protect against radiation. They're thinking inflatable designs.
Yeah, those are promising.
Maybe even underground shelters.
Yeah, that's an interesting concept.
It's pretty cool stuff. But these habitats, they all have to be completely sealed, right? Pressurized, capable of regulating the temperature, filtering out the dust.
Absolutely.
Yeah.
And then there's the whole question of life support.
Right.
We're talking closed-loop systems to recycle air and water. It has to be self-sufficient.
Essential.
And there's some promising research happening. The AMAS UpSea experiment, the Mars Oxygen In Situ Resource Utilization experiment.
Catchy name.
I know, right?
Yeah.
They were able to successfully produce oxygen from the Martian atmosphere,
Wow.
which is huge.
That is huge. Okay. So we can breathe, maybe.
Hopefully.
What are you going to eat?
Right. The other big question, Well, the report explores a bunch of possibilities.
Hmm.
Using Martian soil for agriculture, okay, although we have to deal with those toxic perchlorates in the soil first,
Yeah, right.
hydroponics, growing plants in water,
Hmm.
even potentially supplementing our diet with, like, insects or algae. Water extraction is another huge area of focus.
Hmm.
Scientists are looking into thermal extraction from ice, even pulling water vapor directly from the atmosphere.
Really?
It's all
Wow.
about ISRU, in situ resource utilization,
Right.
living off the land, basically. And all of those robotic missions, they've been crucial in paving the way for this, understanding the Martian environment and actually testing these technologies.
Right. Those robots are the real pioneers,
Definitely.
setting the stage for human missions. And speaking of NASA, with their Artemis program and SpaceX, they're both aiming for human missions to Mars in the 2030s.
Yeah, the report seems to think that international cooperation is likely.
Absolutely. And it's not just getting there, right? I mean, this report talks about so many logistical hurdles. Travel time, that's a big one. It's a long journey, 6 to 9 months each way.
Yeah, that's a long time to be cooped up in a spaceship.
It is. And then transporting all the supplies, landing safely on Mars, that's a challenge because of the thin atmosphere
For sure.
and the psychological impact. We're talking prolonged isolation, communication delays. And this is expensive. We're talking hundreds of billions, if not trillions of dollars.
And that brings us to maybe the most ambitious idea of all, terraforming.
Right. Transforming Mars to make it more like Earth.
Yeah.
So the report mentions some pretty wild concepts,
It does.
like releasing greenhouse gases to warm the planet, giant mirrors in space to reflect more sunlight onto the surface. But some of the core challenges, the low gravity, the lack of magnetic field, toxic soil, limited sunlight, freezing temperatures, that just seems almost impossible to overcome right now
Yeah, the report suggests that NASA's view is that terraforming is not feasible right now.
with current technology, yeah.
They're talking timescales of tens to hundreds of thousands of years just to warm the planet up and then to try to oxygenate it.
That's a long time.
It is. So for the foreseeable future, human life on Mars would rely entirely on artificial environments.
Right, like we're talking about.
Yeah, exactly. And it's interesting, the report draws some comparisons to extreme environments here on Earth,
Okay.
like Antarctica or even the deep sea.
Oh, interesting.
Because in some ways it's similar, right? In Antarctica, it's incredibly cold, dry, isolated. You've got those temperature challenges. You rely on supplies from elsewhere. You need protection from the elements.
Mm,
But there's a big difference.
what's that?
The atmosphere is breathable
Oh, right.
and the gravity is much higher.
Mm.
Same thing with the deep sea. It's high pressure, dark, isolated. But again, some key differences. That pressure, for example, that's the opposite of what we face on Mars.
Right.
And there's no sunlight down there.
Right.
So it's just fascinating to think about how life can adapt to these extremes,
It is.
but how the survival requirements are so different.
It really highlights how unique and how demanding Mars is as an environment.
Absolutely.
So after all of this, what is the expert view?
Well, according to the report, the scientific consensus is that right now, living on the surface of Mars without some pretty radical technological advancements is just impossible.
Right.
Terraforming is not a near-term solution.
Yeah.
And there are definitely some scientists who are optimistic that eventually, driven by exploration and tech progress, that we could live there.
Yeah.
But there are others who are incredibly skeptical because of the enormous obstacles, the cost, the risk.
Right.
So a self-sustaining Martian colony, that's still a really uncertain proposition.
Yeah. So, I mean, the bottom line here is Mars is not exactly waiting for us with open arms.
Not really, no.
We've gone over the extreme environment, the potential effects on the human body, the technological hurdles.
Yeah.
It really makes you think. I mean, considering all of the effort, the resources, the brain power required to establish even just a small outpost on Mars,
Right.
what does that tell us about the importance of taking care of our own planet?
It puts things in perspective.
It really does. Maybe understanding the limits of another world can help us better appreciate the one we already call home and help us protect it.